Midterm Warmups Day 2, Review B. State whether or not 2 to the 6th is a real or imaginary number and explain your reasoning. Well, 2i all to the 6th, I can just use expanded power rule and write that as 2 to the 6th, I to the 6th. So that's what I got to figure out if it's real or imaginary. Let's remember what we know about the imaginary number I off to the side. I know that I comes from the square root of -1. So I equals the square root of -1, the square root of -1 equals I. The cool part about that is that means that I squared is just the square root of -1 all squared. So when I square that square root, I'm left with just -1. And that's a cool feature because I squared is a real number. So what would I to the 6th be then? Let's consider some powers of I, like I cubed, I to the 4th, and we'll work our way up to I to the 6th. I cubed is really just I squared times I. If I write it this way, I can replace the I squared with a -1 and simplify I cubed to -1 times I, which is -I. Well, we can keep doing this and working our way up through the I powers. I to the 4th is just I squared times I squared. So you might be thinking, okay, well, since it's an even number, it's just going to be -1 like I squared was. But pause and think about it. I squared and I squared are both -1. So I to the 4th would be -1 times -1, which is +1. What about I to the 5th? Is it going to be 1, -1, or I, -I? Look at that. I to the 5th is I. Did you find it a different way? Yeah, I mean, you could have split I to the 5th into I to the 4th times I, and then known that I to the 4th was just 1. Or you could do it like I did it and get I squared, I. Up to you. So then what does that mean I to the 6th has to be? It's looking like I to the 6th is going to end up being -1. So if I pop over here, 2 to the 6th is 64, and I to the 6th is -1. So we're going to get -64 as our simplified 2i to the 6th. So that means we get a real number. Take a minute to explain why it ended up being a real number. In my reasoning, I said it's a real number because I raised to an even exponent is always going to end up real. If we kind of look at our work over here off to the side, we can see that. Would 1 minus 2i quantity squared be a real number? What do we have to remember when we square a binomial? We have to remember to write out that binomial twice because squaring a binomial is multiplying that binomial times itself. Then that means we're multiplying out that binomial. Take a moment to do that. Okay, pop quiz, 4i squared. What do we know about that? I know that I squared is just -1. So that's really 4 times -1. So 4i squared is going to just turn into -4. That leaves me with 1. I have -2i minus 2i, which is going to be -4i minus 4. So I can combine the 1 and the -4 and get -3 minus 4i. So that is an imaginary number. For number 3, x plus 1 squared equals 12. This is an equation where we need to solve for x. I think you can do this one. Take a moment to try. I got x equals -1 plus or minus 2 root 3. In this last example, we're asked to consider a solution of a quadratic equation. This example is probably the most important one in this warm-up because we've seen solutions in multiple units, and it's going to appear multiple times on your midterm review. So it's extra important that when I write something extra down on this example, you do as well. Okay, suppose one of the solutions to a quadratic equation f of x equals 0 is x equals -1. So there's our solution. Let's take a moment to consider what it means to be a solution before diving deep into this problem. It says, suppose one of the solutions to a quadratic equation f of x equals 0 is x equals -1. Remember, solutions we have multiple synonyms for. They're called roots, they're called x-intercepts, they're called zeros. So x equals -1, I know I could actually plot on the x-axis right there at -1, 0. It says blank is a factor of f of x. If I know a solution, I actually know part of my factored form. Because think about it. If I had f of x equals 2x minus 1 and x plus 3, right? Then when I go to solve to find my zeros, I would just set it equal to 0 and drop my curtain using zero product property, set each factor equal to 0. So 2x minus 1 equals 0 and x plus 3 equals 0. I'm going to get x equals -3 and x equals 1/2 when I solve. Well, if those are my solutions, they're asking me what would your factor have been? So when x was -3, my factor was x plus 3. So what would my factor be if x is -1? X plus 1. The point blank is a location of the x-intercept on the graph. Well, hey, I already drew that. The point -1, 0 is a location of an x-intercept on that graph. Then it says the second solution of the equation f of x equals 0 is always, sometimes, or never a real solution. Okay, that's a deep question. We really have to consider what this graph would look like if it had that solution at -1. What are our possibilities? Well, one possibility is that the graph crosses at -1, loops down or loops up, and then comes back through the x-axis. So that would be a two-solution possibility. And both those solutions would be real because it's occurring right there on that x-axis. Well, another solution, okay, I could have -1 again. I could have just looped the other direction. So there's two solutions again, two real solutions. I could have, is there a possibility we could just have one real solution there? Well, if we pop down, tap that solution, and bounce back up, we know that that's a one solution situation, but the multiplicity would be 2 because there's a bounce there. Am I missing a situation? 2 solutions, 1 solution. I still have the case where I have no real solution. We're going to talk more about that case in a second, but just think about what it would look like. You'd have like a quadratic parabola, kind of either down in the bottom, pointed, opening down so that it's not going to cross the x-axis, or up top, opening up so it's not going to cross the x-axis. So if for sure I have one real solution because I have it right here, then I know that the other solution is either going to be a duplicate, so it'll be -1 again, or it's going to pop through the axis at another place, like my two solution situation. My second solution always has to be real. For quadratics, it's like they're going to come in pairs. So if one solution is real, the other solution has to be real. I wonder if that's true for imaginary as well. So this is where we're going to dive in a little bit more to this example and talk about it, which will be important later because it'll come in handy. So let's consider the quadratic y equals x minus 3 squared plus 4. And think about the solutions. Well, we can graph that because it's just in transformation form or vertex form. So I know that it's shifted to the right 3 and up 4. So 1, 2, 3, 1, 2, 3, 4. And it's positive in the front. So I know over 1, up 1 on each side, over 2, up 4 on each side. So there's my quadratic. If I solve this old school, so I clearly know it matches this example, but I'm going to go solve this equation old school. So 0 equals x minus 3 squared plus 4. I'd subtract 4 from both sides and end up with -4 equals x minus 3 squared. When I square root here, this is when I'm going to end up with some imaginary numbers. Plus or minus 2i equals x minus 3, and then I'd add 3 to both sides. So my solutions end up being imaginary, and notice how they come in a pair. It's going to be 3 plus or minus 2i equals x. So if I'm given that I have an imaginary solution, then I know that the other solution always also has to be imaginary. That'll come in handy later, so keep that in mind. Then it says blank is a 0 of f of x. Remember, 0 is just a synonym for solution. So I can say -1 is a 0 of f of x.